So this third question here is about organic chemistry. So we have an undesirable 7 carbon chain hydrocarbon. Blah blah blah. There are 9 structural isomers. So what is meant by structural isomers and what is meant by chiral center? There will always be marks and definitions. If I were you, I would list down all my AS and A-level chemistry definitions, just like with chemistry, biology, physics, whatever. And then you should prepare this list of definitions in your own booklet, in your own notes, so that you can review it as you need to from time to time. Instead of reading, you're actually reviewing it again and again to consolidate your memory, and you'll have better retention. So structural isomers, from the name itself, they are molecules or compounds with the same molecular formula. There's the key thing. They must have the same molecular formula. So that means they have the same actual number of atoms in the molecule, in one single molecule. But what is different? Because of the name itself, they must have different structural formula. When you write out the structural formula, that looks different because they are structural isomer. As for chiral center, you're looking at a carbon atom, and this carbon atom is bonded to 4 different groups. 4 different groups, well, in fact, 4 different atoms or groups of atoms, because it could be just atoms or it could be groups of atoms. I guess 4 different atoms or groups should be okay, and therefore you will get non-superimposible mirror images of each other called enantiomers. Now, what are the structures and the names? They don't mention what kind of formula they want. You could give displayed, you could give structural, you could give skeletal. If it were up to me, I would always go for skeletal first, because this is the fastest one and this is the most elegant one that you need to get used to. No matter how much you hate it, you have to learn until you can do it properly, because in A2, there's no way you would draw display for such a big molecule. I mean, C7 is still okay, but sometimes you get rings and other big molecules where it becomes almost impossible. So master your skeletal whether you like it or not. Now you want structural isomers of C7H16, and you want this contain a chiral center. So you're not asked for every single isomer. So if I were you, I would start off from 1 carbon like that, and then I would draw 2 carbon like that, because 1 carbon, 2 carbon. Now I'm going to draw 3 carbons, 1 carbon, 2 carbon, 3 carbon, 1, 2, 3, 4, 5, 6, 7. And I have a hydrogen there. Carbon from 4 bonds, 1, 2, 3. There is a hydrogen there. So that means this is a chiral center there. And if I'm asked to name this, so I mean, I already got on the structure, I just need to name it. Then I will look for the longest chain carbon. That would be alright, but if you are thinking about the other way around, the pink one will not be alright, because the 4, the branch group is at position 4. 4 is bigger than 3, so pink one is not correct. You want the lowest number for the branch there. So what we get must be 3 methyl, because your side chain is a CH3 methyl branch, and 6 carbon is hexane. Now we also want a chiral carbon for the other one. This one is the starting point for you. You can't do anything on this 1 carbon and 2 carbon. But when you have 3 carbon straight chains, you know you can branch it further. So I'm going to draw this 1 carbon and 2 carbon the same way. I'm going to branch out. So straight chain, and then I'm going to do a branch chain. This is called chain isomer. So instead of that 1, 2, 3, I'm going to do a branch like this. So this 3 carbon is now a branch from this 3 carbon straight chain there. Onto my numbering, 1, 2, 3, 4, 5. Well, you could be thinking of that, or we could be thinking of, let's say, the green color one. 1, 2, 3, 4, 5. Where is our branch now? If I go the blue color one, as I did before, 3 and 4 is my branch, 3, 4 dimethyl. If I go the green color, 2, 3 dimethyl. 2 and 3 are smaller than 3 and 4. So obviously the blue color one is no longer applicable here, as that does not give you the lowest numbering possible. This is 2, 3, and they are both dimethyl. They are both methyl. So now I have 2 methyl is called dimethyl. They are at position 2. They are at position 3. And my longest carbon chain now is 5 carbon. So my longest chain is now 5 carbon. It's called pentane there. On to the next question, write an equation, that means one equation. They don't say the equation, which means there could be one. Could there be more than one answer? No, there can only be one answer, right? Because complete combustion will give you just CO2 and H2O. So heptane was C7H16. Forget the formula. Well, have a look at here. C7H16, that is CnH2n plus 2. General formula of alkane homologous series back then in O-level GCSE or IGCSE level chemistry. So do not get this thing wrong. Plus O2, and you get complete combustion, so CO2 and H2O. 7 carbon there, so you will balance with 7 CO2, 16 hydrogen there, you balance with 8 H2O. Now you have 8 oxygen, and you have 14 oxygen plus 8 oxygen is 22 oxygen. 22 oxygen, and you have a molecule. You cannot change these two at the bottom. You must have 11 O2 like that. Now part 2, you want incomplete combustion. Incomplete combustion could give you multiple products. They could give you carbon monoxide. They could give you carbon soot as this black solid. But then they want specifically a solid pollutant. A solid pollutant. So you're looking at the formation of carbon. But you could also produce carbon dioxide or carbon monoxide. So let's just try and balance our equation. So that means not enough oxygen. Basically, incomplete combustion means not enough oxygen. I'm going to just produce carbon first. But they don't say you cannot produce any other thing. So I'm not sure if I can balance my equation if I just do like this. If I have 7 carbon, then I have 16 oxygen. I can never balance it because, can I? Well, actually I can. 7 carbon and then 16 hydrogen. So 16 hydrogen, 8 oxygen. Then I'll have 4 O2. Or you could have other equation, other possibilities, where you have lesser carbon produced, but you can produce CO or carbon dioxide, etc., etc. As long as the equations are balanced, as long as you have a solid pollutant, the carbon soot there. Incomplete combustion can also lead to emission of unburned hydrocarbon. Because you don't burn completely as you don't have enough oxygen. What is the danger of unburned hydrocarbon? This is a very specific thing of unburned hydrocarbons. So the danger is on unburned hydrocarbon that can cause photochemical smoke. So this is a photochemical smoke like in Beijing, which has a lot of industry obviously, and this thing can result in breathing problem or respiratory distress. But the idea is the photochemical smoke, and they can cause breathing problems. Now part C is about free radical substitution mechanism, and you need the presence of UV light. You get a wide variety of products. That is why this is called a chain reaction. It's like nuclear reaction. You can't control it because it's very reactive. Radicals are very reactive. Propagation especially is quite hard to control because it just spread everywhere. Propagation there. So what we're going to be thinking about, name the mechanism. The type of reaction is substitution, stated in AS introductory, all the terminology. Type of reaction is substitution. The mechanism is called free radical substitution. The next bit obviously want you to write out the mechanism step by step, and you got to include the names of each stage. You got to describe the mechanism. Instead of using a lot of words, try to write the equation correctly. You have 5 marks. So we got to write a lot of equations as well. So the first thing that will happen is initiation. So in the initiation stage, the CO2 breaks by homolytic fission. Homolytic fission is a term stated in the AS introductory chemistry syllabus. Basically, the covalent bond breaks equally so that you have half-headed arrow. You don't use a full-headed arrow because it's not 2 electrons, it's 1 electron. 1 electron goes there, 1 electron goes there. And this only happens in the presence of UV light, and you will get radical. So breaks by homolytic fission to form chlorine radicals. So these are called radicals. Species with unpaired electrons are called radicals, definition of which is stated in the AS atomic structure topic as radical definition there. And then revisit these under introductory organic chemistry as well. So the next thing will be your propagation. So propagation comes from the English word to spread, okay? So radical reacts with molecule. So molecule has no charge, it's not radical, to form another radical, and then another molecule and another molecule. So you must have radical on the left and you must have radical on the right. That is the idea of propagation. So if I have one of these chlorine radical and I react with C7H16, the first product I'll get will be HCl, as it takes away the H from there. And when this loses a H, the C7H16 will lose a hydrogen. I now have C7H15. I must have a radical. I'm not saying the dot, the radical, is on the hydrogen. It's actually on the carbon when you think about it. And then we cannot stop there. Propagation, you need to show at least 2 steps because you haven't gotten to the product in the propagation step. This is the product that you want. This is a single substitution when you replace one hydrogen with chlorine. This is an overall reaction. It's not the mechanism. The mechanism is what happened in detail. So I still have to show C7H15 dot. So I have my radical C7H15 dot. I react it with a molecule, another molecule of Cl2. Molecule is not radical. So then I would form my molecule, which is C7H15Cl. No longer radical because I pick up the Cl radical, and then the Cl2 will form me another radical. Radical plus molecule give me molecule and no radical. Essentially radical on the left, radical on the right. Okay, you form a different molecule, you form a different radical. Last but not least, you have something called termination. So initiation is going to be the slowest step, as you need to break bonds without forming anything. Highest activation energy, you need the UV light to initiate this process. In termination, what happens is radicals recombine. This is the key idea in termination step, recombine to form a molecule. So that means radical and radical, and then no radical. It's the opposite of initiation. It's the fastest step because you are forming covalent bond without breaking any covalent bond at all. So what we get is things like Cl dot and then C7H15 dot. So I could probably write like this, but then I will have C7H15 dot plus Cl dot giving me C7H15Cl. So radical and radical recombine to give me no radical there. That is termination step and the end of the 5-mark mechanism question.